So your polynomial is, it is made up of two words, poly plus nomial. Okay. Okay. So poly means many. Poly is just many. And nomial means terms. Actually, this can be, nomial could be a number, it could be a variable, or it could be product of number and variable. So for example, 2, well, that's a term. X is a term. 2x is a term. XY is a term. Okay, so a term could be a number, it could be a variable, it could be product of a number and variable, or it could be product of two different variables. Okay, so if you have many terms, now as you said, there is monomial, there is binomial, trinomial, and after trinomial we have a after trinomial we have quadrinomial with 4 terms. After quadrinomial, we just call it polynomial. We don't have any special names after quadrinomial. So in general, you can write a polynomial like this: an times x raised to n plus an minus 1 times x raised to n minus 1 plus so on plus a1x. And here's the last term, a0. These are just, okay, so what are these? an minus 1, a1, a0. These are called your coefficients. an minus 1, a1, a0. These are coefficients. I mean, you know this already, right?
Yeah.
Yeah, okay. And if you put it equal to f of x, then this becomes a polynomial function. Now this entire thing, and this is what we will be dealing with in this chapter. This is a polynomial function. Polynomial function. Now in this function, your an, that is called the leading coefficient. Leading coefficient. Okay, it is a coefficient of the highest power of x term. Here, an is the leading coefficient, and this guy, n, this is called the degree of the polynomial.
Yeah.
Okay, and this last term, a0. Now, in this term, there is no variable, right? This is just a constant. A0, these are an minus 1 up to a0. These are all some constants. And in the last term, you don't see any variable. This is just a constant. Okay.
Yeah.
And whenever you write a polynomial in descending order, in decreasing order of exponents from left to right, so that is called the standard form of polynomial. This right now it is written in the standard form. Okay.
Yeah.
Okay. There are certain criteria that you should know which make a polynomial a polynomial, and in some cases you will see some functions, they might look like a polynomial but they will not be polynomial. So there are some conditions which are not allowed in a function to make it a polynomial. I'll give you some example and let's see if you can identify the polynomials. So I'll write some functions. Okay, so we have 4 functions. And out of these 4 functions, some of them are polynomial functions and some of them are not. Okay, so with this example, you'll understand that what are some conditions that make a function a polynomial. What do you think? I'll give one more. And there is a second part to this question, but I'll tell you that second part later.
Okay.
Let's start with f of x.
Okay, so for f of x. No, that's a polynomial.
It's a polynomial? Okay.
Yeah.
Yeah. Okay. Then g of x.
No.
No? Okay.
Well, I mean, doesn't it have to be in standard form? Because like square root of 2x to the power of 4 has to be first.
It's not written in the standard form. I agree, but even if it's not written in the standard form, it is still a polynomial.
Oh,
So you don't have to think about the standard form.
okay, then put it as a polynomial.
It is a polynomial, okay. H of x.
To the power of -1. Is that power to the -1?
Hmm.
Oh. Yeah, that's a polynomial.
Okay. Okay. So with this part, I'll tell you one condition that you have to remember for polynomials. The exponents that you see in the polynomials, right? These exponents.
Yeah.
These exponents should be whole number. Okay. That's the first condition. Okay, so all these exponents here, n minus 1 up to so on, they should be whole numbers. And -1 is not a whole number. In fact, any negative number, -1, -2, -3, -4, -5, they're not whole numbers, right? So
Yep.
this one is not a polynomial because of this term. Okay, what about k of x?
Oh, okay, so that, I mean, that's a binomial, but it can still be considered a polynomial, but 3 to the power of x?
Yes.
I don't think that should be considered a polynomial.
Yes. This is also not a polynomial because your variable cannot be in the exponent. Variable cannot be in the exponent, okay? That's the second condition. Now, what about j of x? That's a tricky one.
Oh, oh my god, no, then you can put, that's not fair.
What?
Oh yeah, that's not a polynomial.
That's not a polynomial?
11x. Oh wait, no. Ow.
This is a tricky one.
Okay, so that's 11x. -x to the power 2. Okay, that's right. -4 divided by x to the power of -2. Wait a minute, what was that? Yeah, that's a polynomial.
Are you sure? Final answer?
Yeah.
But why it's a negative exponent here?
I don't know. I don't think it is a polynomial, but there's this one rule that I've like remembered about like negative exponents on the bottom of a fraction that you can just like do that so that it could be considered a polynomial. But you're making me second guess myself, so I think it's a polynomial.
Okay, it is a polynomial because you were in the right direction. So this is, if you remember the rule, if you have a negative exponent anywhere, if you see negative exponent, let's say we have negative exponent like this. So this can be written as x raised to a. Whenever you see negative exponent, you just take the reciprocal of that term. So this is x raised to -a. So what is reciprocal of x? 1 over x,
One
right?
1 over x. Yeah.
So you will write it as 1 over 1 over x.
Oh, and
And
that's just, oh, okay.
yeah, and the moment you take the reciprocal, the exponent becomes positive. So we wrote x as 1 over x, right? So
Yeah.
negative a became a, and 1 over x raised to a is actually x raised to a. So this term is basically negative 4x squared. Okay, so this is a polynomial. So if you see a negative exponent in the denominator, then that they're just trying to trick you. That will be a polynomial. Okay, and what about if you have a square root or a radical, any radical on the variable? Like square root 2 is fine, but what if the root is on the variable?
Then I don't think that would be allowed.
Why?
Isn't 3 the degree or x?
No, degree is the exponent of the variable. Highest power of the variable. But
Okay.
you don't.
Oh, yeah, then it should be considered a polynomial if you put it in there.
So we are not concerned about the degree. We are concerned about all the exponents, all the powers. We have to check all the exponents. And I just told you that the exponents should be whole numbers.
Okay.
Exponents of every variable. Whatever variable you see, the exponent should be whole number. Now, when you have square root of x, that's a radical. This is x raised to 1/2. This is x raised to 1/3. Okay, and 1/2 and 1/3, they are not whole numbers, right?
Yeah.
This is not a whole number. This is also not a whole number. So if you see square root, like if you see the variable under a root, square root, cube root, fourth root, fifth root, then also it won't be a polynomial. These are all the conditions that they can give you in a question to identify a polynomial. So you know that only two conditions you have to remember, that the exponents should be whole number and the exponents cannot be, the variable cannot be in the exponent like here.